If you're building anything serious in the cloud, you know this headache. You have a business process that takes hours, maybe even days to finish. Now, these long-running workflows, they're the engine of modern business, right? But man, they are incredibly fragile. So in this explainer, we're going to break down the essential design patterns you need to build them the right way. I want you to picture this. A critical report, maybe for finance, has been chugging along for 3 hours. It hits 99% complete. And then, boom, it fails. Everything just grinds to a halt. Now what? What's the recovery plan? And look, this isn't some hypothetical nightmare scenario. This is the high-stakes reality for architects managing critical systems every single day. So what is it that makes these processes so darn fragile? Well, the core issue, it all comes down to one word: state. You see, in a distributed cloud environment where services can pop in and out of existence, trying to maintain consistency over a long period is, well, it's incredibly difficult. A single glitch can corrupt the entire workflow. So this is the battlefield we're talking about. We're not dealing with simple, quick requests. We're talking about workflows that can span hours, even days, trying to coordinate dozens of different microservices. And it doesn't matter if you're using AWS step functions, Azure Logic apps, or running it all on Kubernetes, the fundamental challenge is exactly the same: keeping that state reliable from start to finish. All right, to make all this a bit more concrete, let's stick with one simple example throughout this whole thing: an e-commerce order. This is going to help us see how these kind of abstract patterns actually play out in the real world. First up, let's look at the ideal scenario, what we call the happy path. In a perfect world, right, the flow is just beautiful. It's perfectly linear. A customer places an order, their payment goes through, the inventory system gets updated, and the order ships out. It's clean, it's simple, it's straightforward. Each step just seamlessly triggers the next. Easy. But this is where reality hits. What if the payment gateway is down for a minute? Or what if the inventory service fails right after you've charged the customer's credit card? This is where our perfect little flow just completely shatters. And without the right architecture, it creates a serious, serious mess. So, how do we solve this? How do we fix it? Well, we use proven design patterns. Think of these as the essential tools in any cloud architect's toolkit for building systems that are not just successful, but resilient and reliable, even when things inevitably go wrong. The most important pattern for this problem, the real heavy hitter, is the saga. What it does is it reframes our workflow as a series of local, independent transactions. But here's the magic trick. If any step fails, the saga executes what we call compensating transactions. These are basically actions that systematically undo the work that was already completed. This ensures the system never ever gets stuck in a broken, inconsistent state. Just look at the difference here. It's night and day. Without a saga, the inventory update fails, and now you've got a customer who's been charged, but no item was ever reserved for them. That's a huge problem. But with a saga, the pattern detects that failure and automatically kicks off the compensating transaction, refund payment. The system literally cleans up after itself and gets back to a valid, consistent state. Okay, so this gets us to the heart of our error handling strategy. You know, a mature architecture isn't about trying to prevent all failures. That's just impossible. It's about gracefully handling the ones that are absolutely going to happen. Planning for success is the easy part. Building in resilience is what separates great architecture from just good architecture. And the very first step in handling any failure is to classify it. You simply cannot treat every error the same way. Is it a temporary network blip, what we call a transient failure? Or is it a fundamental problem, like an invalid credit card number, a permanent failure? Your entire response strategy depends completely on that distinction. This gives us a really clear playbook. For a transient error, like that network timeout, we don't just give up. We use a smart retry strategy, like exponential backoff with jitter, which basically means waiting progressively longer between each retry to give the other service a chance to recover. But for a permanent error, retrying is pointless. It's never going to work. We need to fail fast, alert a human, and kick off those compensating transactions we just talked about. Now, for any of this retry stuff to be safe, we need another critical concept: item potency. It sounds kind of nerdy, but the idea is actually super simple. It just means that you can run an operation multiple times, but it has the exact same effect as running it just once. Think of it like a safe-to-retry switch for your services. So why is this so critical? Well, think about it. If your retry logic accidentally calls process payment twice, an item-potent design makes sure the customer is only charged once. It's what stops you from pulling two items from inventory for the same single order. Idempotency is what turns a potentially dangerous retry into a safe and reliable recovery mechanism. Okay, let's pull all of this together. We've talked about sagas, classifying errors, and idempotency. Now, let's distill this down into a practical toolkit that you can use for your own long-running workflows. This right here is your checklist for resilience. It starts with sagas for managing state and ensuring consistency. Then you absolutely have to classify every potential failure so you know how to react. For those transient issues, you're going to implement smart, idempotent retries so they're safe. And finally, for every single action, you need to build its opposite, the compensating transaction that can undo the work if it all goes sideways. You know, this really requires a shift in mindset. We're not trying to build a perfect, unbreakable system. That's a fantasy. The real goal of a great architect is to build a system that expects failure and knows exactly how to recover with grace and predictability. And that's the bottom line. Resilience is the true measure of a mature system. It's having the confidence that when some component inevitably fails at 3 a.m., your architecture knows exactly what to do, how to handle it, clean up, and keep the business running smoothly. And that's really the question I want to leave you with. Take a hard look at the systems you're designing today. Are they built on a prayer, just hoping that nothing ever goes wrong? Or are they built with the wisdom that things will fail, and they're designed from the ground up to survive? That choice, right there, defines your architecture.